use the data at the back of the book to determine delta H for the combustion of a mole of glucose. This is the net reaction providing most of the energy needs. Okay, so we know that the delta H for the reaction will be however much energy we have in the products per 1 mole to make these molecules, how much is stored in their bonds, in their chemical bonds, and also how much energy is stored in the space to make them, minus the same exact thing for the reactants. So if we go to the table at the end of the book, page 104, we can see that the delta H for this reaction will be this is the delta H in CO2, and the data in the back of the book is for 1 mole. So I would have to multiply this by 6 and then add it to that of liquid water. 6 delta H for H2O minus those of the reactants, because we are going from reactants to products. So the net would be how much we created minus how much is the what was formed, or what were they formed from, which is glucose and oxygen. So this will be delta H for glucose. I'll summarize it as G times 1 plus 6 times delta H for oxygen, O2, which would be 0, by the way, because this is the amount of energy it takes to create the molecule from its constituent elements, but O2 already exists as O2, so it doesn't take any energy, more or less, to make it, so the last one would be 0. Okay, so if we look at the data in the back of the book, that for CO2 gas is negative 393.51. And the units here is in kilojoules. Okay, plus 6 times that of liquid water, which is 285.83. minus that of glucose is 1273, negative 1273, and this whole thing is in joules or kilojoules. Okay, and so plugging this in, negative 2803 kilojoules for every 1 mole of glucose. This concludes this problem.